Welcome back. As we continue our chapter in solutions, we're getting ready to discuss one of the most powerful formulas you can have in relation to solution concentration. This formula is hang in there, the dilution equation. So the dilution equation is going to allow you to figure out how much of a solution you need to prepare a diluted solution. If you want a diluted solution, how much water you need to add. If you want a specific concentration, how much of the original solution you have to use, and all that. So it's a very powerful formula, and it's so simple to use. So let me show you by doing this problem. So the problem is, how would you prepare 500 milliliters of a 0.25 molar solution if you begin with a 15.0 molar solution? So before we do the problem, let's make sure that we understand what this is talking about. It's telling me that I'm going to begin with this solution, which is 15.0 molar. And I want to prepare a solution that is 0.25. So I'm going to go from 15 molar to 0.25. Therefore, I am diluting it because I'm making it less concentrated. So, and it's also telling me that that I want to specifically get 500 milliliters. So it's not just any amount. I know exactly how much I want of the new solution. So how do I do that? Well, let's use let me show you the formula. That's the formula. Given the initial concentration to prepare the diluted concentration, and I want it to be a total volume of 500, how much volume of the concentrated one do I need to use? So that's all it is. It shows you the original concentration, the amount of volume of that concentration that you need to use to make a specific amount of volume with a specific new lower or diluted concentration. So this problem is telling me that I want to prepare 500 milliliters. So that's going to be my B2. So that's how much I want to prepare. It's also telling me that the new concentration is going to be 0.25. So M2, 0.25. And by the way, this concentration doesn't have to be molarity. It could be mass percentage. It could be molality. It could be mass volume percentage. So as long as your N1 and N2 are the same unit, you can use any concentration. And in addition to that, it's telling me that my stock solution, the stock solutions are the ones that are very concentrated, is 15.0 molar. So N1 is 15.0 molar. And the reason we use this formula is because if you're working on a lab, what you do, you order a very concentrated solution and you use that solution or that stock solution to prepare as many molarities you need that are less concentrated than that one. So you can always dilute it to get whatever concentration you need that is lower than the stock solution. So as you notice, the only thing that we do not have is the B2. So that's what we're looking for. So it's just a matter of taking N1, B1 equals N2, B2. I'm looking for B2, so I'm gonna get rid of I'm gonna leave it by itself by dividing by M2 on both sides. This cancels M2, so N1, B1 over M2 equals B2. So for this particular problem, M1 is gonna be 15.0 molar. B1 is going to be, sorry, I got something, no, yeah, I got something wrong, and this is what I got wrong. That's not B2. I already got B2. That's a B1. So N1, B1, B2. So I'm looking for B1. Let me start this part again. I'm looking for B1, not B2. Sorry for that. So N1, B1 equals N2, B2. I'm looking for B1, so divided by N1 on both sides. So B1 equals N2, B2 over N1. So I'm back on track now. Sorry for that. Excuse me. So B1 is going to be M2, which is 0.25 molar, multiplied by B2, which is 500 milliliters, divided by M1, which is 15.0 molar. So the M's cancel. And when I do this problem, the answer should be, just give me a second. When I do that operation, I'm going to have 0.25 multiplied by 500. There's no need to change it to liters. Divided by 15. And that's going to be 8.33 milliliters. Because that's the only unit that didn't cancel. So what this is telling me is that B1 is going to be 8.33 milliliters. And if we stop there, you just did whatever kid on third or fourth grade can do. You plug numbers into the formulas and so on. You haven't done any chemistry at all. So what does that mean? That means that from the stock solution, which is 15 point molar, I'm going to take out 8.33 liters. So if I have my stock solution, they usually come on containers like this. And this is 15.0 molar. I'm going to take a pipette or something like that, and I'm going to bring out 8.33 milliliters. Then, since I want a final solution of 500 milliliters, I'm going to grab a volumetric flask that is going to look something like this. And this volumetric flask will only have one line there, which tells you that if you make it to the line, you got 500.00 milliliters. They're a very expensive piece of lab equipment, and you had one on your lab kit, a small one, by the way. So 500 would be bigger. And they're expensive because they're very precise. And what you're going to do, you're going to take 8.33 milliliters, you're going to put it there. And then you're going to take distilled water and you're going to add it in there all the way until you get your meniscus right on the 500 mark. So at that point, and then you just shake it. You can flip it upside down. Make sure you mix it, make it a very homogeneous solution. And by the time you finish, your new concentration is going to be 0.25 molar. So that's how we use the dilution formula. N1B1 equals N2B2. It's not a matter of just finding the unknown. It's a matter of once I find the unknown, do I know what I need to know to be able to prepare this solution? Yes. B1 is how much you need from the stock solution. You need to get a volumetric flask that gives you exactly the volume you want, and then you're going to dilute it with distilled water until you reach that point. That gives you the new molarity. So that's the most important you need to know, how to use the dilution equation and what does it mean in terms of making the solution on your own. So with that said, Go ahead and do this daily work. And once you are done with that daily work, then you can do this one, which requires deeper thinking about what this formula actually means. And go ahead and do step one, I will do this, step two, I will do this, and so on. I will use this equipment, I will do this, and I will do that. If you get confused, refer back to this recording when I was explaining what B1 means in terms of what I need to do. And once you do that, you know the dilution equation now. You know how to use it in calculations, and even more than that, you know how to use this formula to work on a lab. And you can, this can be, it doesn't have to be a chemistry lab, it could be a biology lab, it could be a medical lab, it could be an engineering lab, so many things. It could be your kitchen if you are into cuisine and stuff like that. So let's leave it like that, there for right now. When we come back, we are gonna use what we have learned about molarity, not the dilution formula, but what molarity means in terms of liters and moles, and we're gonna start using that to do a stoichiometry. Basically, if you have a balance equation, and I tell you how much you have of one of the reactant, can you tell me how much product you can make? But instead of doing it with grams, instead of doing it with moles, or doing it with pressure and volume, where we use PV equals nRT, now we are doing it with molarity. Stoichiometry always requires for you to find the moles, and molarity allows you to find the moles given the volume of a solution. So that's what we're going to do when we come back. So let's leave it there for now. See you soon.